everyone, our today's topic is electric potential, that is Vp, that is at a point electric potential at a point P is equal to minus integration infinity to point P E bar dot dl bar. So this infinity is the point from which we pick up the charge and the point P is the point. At that point we have to drop the charge. So Vp is equal to minus integration infinity to point E bar dot dl bar. So this is the formula for electric potential. So in this lecture we discuss some examples on electric potential. Suppose we have a hollow sphere like this. This is our hollow sphere, okay, and the plus charge plus q charge on that sphere. Okay, this is the plus q charge on that sphere. So we have to find the electric potential at a point. That is, suppose the radius of that hollow sphere is capital R, and we have to find the electric potential. It is first when R is greater than R, second when R is equal to R, third when R is equal to, R is less than capital R, and the fourth is R is equal to 0. Okay, so we have to find in these four cases electric potential. So consider the first case, that is R is greater than capital R. Suppose this is our hollow sphere. Okay. Suppose this is our hollow sphere here. Okay, 1 minute, we have to rub this. Suppose for first case R is greater than R. So this is our hollow sphere. Okay, the plus q charge resides on the surface of that hollow sphere. Okay, and we have to find the electric potential at a point R is greater than R. So suppose this is the point P, and the distance from the center is R, okay, which is greater than the radius, capital R. So at that point we have to find the electric potential. Okay, so we know that the electric field at that point is E bar is equal to 1 upon 4 pi epsilon naught q by this distance of that point from the center is small r. So this is r square r k. Okay. So we have to find the electric potential at that point. So we have to pick up a charge from infinity. Okay. Suppose this is the infinity, and we have to pick up the q charge from infinity. Okay. So we pick this q charge from infinity and we drop this q charge here at point P. So for that we have to calculate the electric potential. So V at that point, that is Vp. So we know that the formula for calculating the electric potential is Vp is equal to minus integral infinity to that point, that is P, it is E bar dot dl bar. Okay, so this is the sphere, so dl is dr r cap. Okay. So we have to find the electric potential at that point. So electric field at that point is E bar is equal to 1 by 4 pi epsilon naught q by r square r cap. So we can put this value here. Okay. So Vp is equal to minus, it is the limit of that is this from infinity. We pick up the charge from infinity. So this is infinity to, we drop this charge at a point P, and this point P is at a distance small r from the center of that hollow sphere. So the limit of this is infinity to, this distance is r. So infinity to small r. E bar, what is the value of E is 1 upon 4 pi epsilon naught q by r square. This is TL is d, so r cap dr r cap. Okay, so what it becomes, Vp is equal to minus infinity to r. This, suppose we take this constant term outside, that is minus q by 4 pi epsilon naught. This is the constant term, so we take it outside of integration. So this is the q, sorry not a q, 1 by r square dr. So the integration of 1 by r square is minus 1 by r. So Vp is equal to minus q by 4 pi epsilon naught to minus 1 by r and limit infinity to r. So this minus minus becomes plus. Vp is equal to q by 4 pi epsilon naught, and this, when we put this upper limit, that is 1 by r, and when we put this lower limit, that is 1 by infinity, it becomes 0. So only we put this upper limit. So this is the Vp, or it is Vp, that is the potential at a point V. P is 1 by 4 pi epsilon naught q by r. So this is the potential at a point P, okay, due to this hollow sphere. That is the when our r is greater than r, the potential is Vp is equal to 1 upon 4 pi epsilon naught q by r. Case is when r is equal to capital R. So suppose this is our hollow sphere, okay, and the plus q charge is resides on the surface of that hollow sphere. Okay, this is the plus q charge, and the radius of that hollow sphere is capital R. So we have to find the electric field at a point when this R is equal to capital R. It means that we have to find the electric potential on the surface of the hollow sphere. So for that we have to first pick up the charge from infinity. So suppose this is the infinity, and we have to pick up any charge from infinity, and we have to drop that charge on the surface of hollow sphere. At this point we drop, suppose this point is P, and the distance of that point from the origin is capital R. So we have to find the electric potential at that point. So first we know that the electric field, that is E bar, at that point is E bar is equal to 1 by 4 pi epsilon naught q by r square. So r square, because the distance of that point from this center is capital R, so this is r square. So we know that this is the electric field. So we have to find the electric potential, and the formula for the electric potential is Vp is equal to minus integral infinity to the point r. Okay, so we have to pick up this charge from infinity and drop at point P. So this point is a capital R distance from the center. So this is infinity to capital R E bar dot dl bar. So this is minus infinity to R. What is the value of? That is E is 1 by 4 pi epsilon naught Q by capital R square dr. Okay, so Vp is equal to what is the constant here? Minus 1 up, Q is also constant here, that is Q by 4 pi epsilon naught integral infinity to R 1 by R square dr. So here we can take this dr is capital dr because we take this capital and so this is dr. So Vp is equal to minus Q by 4 pi epsilon naught. So this is the integration of that is minus 1 by r. Okay, that is minus 1 by r, and the limit of that is infinity to r. Okay, so this is minus minus plus Q by 4 pi epsilon naught Vp is equal to, and 1 by r, when we put this upper limit, that is 1 by r, and when we put this lower limit it becomes 0. So that is Vp is equal to 1 by 4 pi epsilon naught Q by r. So this is the electric potential on the surface of hollow sphere, that is 1 upon 4 pi epsilon naught Q by r. So third condition is that when r is less than capital R. So inside the hollow sphere we have to find the electric potential. So suppose this is our hollow sphere. Okay, plus Q charge on that hollow sphere. Okay, this is the plus Q charge reside on the surface of the hollow sphere. Okay, and the radius of that hollow sphere is r, and we have to find the potential inside the hollow sphere, that is r is less than capital R. Suppose at that point we have to find the electric potential. So the distance of that point from the origin is small r. Okay, so for that we have to first pick up the charge. Okay, so this charge is at infinity. So we have to take this charge, okay, from infinity. Okay, right, like this. The first station for that charge is on the surface of that sphere. Okay, so at a distance capital R is the first station for that charge. The next station for that charge is from that capital R to this charge goes at a point P, which is at a small distance, or at a distance r, small r, from the center O. So, and we know that the electric field is 1 by 4 pi epsilon naught Q by R square. So, the formula for finding the electric potential Vp is equal to minus infinity to that point. Okay, suppose this is at a point R. So, infinity to R E bar dot dl bar. So Vp is equal to minus, we have to put the value of this electric field. So this is the infinity to R, 1 by 4 pi epsilon naught q by R square dr. So Vp is equal to, the first we take outside the constant term of integration, that is q by 4 pi epsilon naught, the integral infinity to R 1 by R square dr. But here two destination or two station for that, is we divide this limit, that is first limit is for that Vp is equal to minus infinity to this infinity to the capital. So first station for that charge is infinity to capital R. So infinity to capital R 1 by, so you take only, you can also write here q by 4 pi epsilon naught 1 by R square dr, and the second station of that charge is from R to small r. So minus, that is capital R to small r q by 4 pi epsilon naught 1 by R square dr. So here we take constant term outside, that is minus q by 4 pi epsilon naught infinity to R 1 by R square dr. But here inside the hollow sphere the electric field is 0. So here inside the hollow sphere, in the limit of R to R, this electric field is 0. So this is 0, this is 0. So Vp is equal to minus q by 4 pi epsilon naught, and the integration of this is minus 1 by R, limit from infinity to capital R. So Vp is equal to q by 4 pi epsilon naught, when we put this upper limit is R. So this is the value of Vp, that is Vp, you can take this, Vp is equal to q by 4 pi epsilon naught R. So this is the electric potential at a point inside the hollow sphere, at a point P. This is the electric potential.